My name is Ahmed, and in this section, we are going to start deploying our main application using Docker. The application that we are going to deploy is the MEANstack. MEAN stands for MongoDB, Express.js, Angular.js, and Node.js. The interesting thing about the MEANstack is that all the components use JavaScript as the coding language. Docker will help us deploy this application using the microservices architecture. In this architecture, the application components are decoupled from each other. So, our application will have a backend database running MongoDB on a container. This will be responsible for saving and retrieving data off the disk. The application server will handle the application logic on another container. It will interchange data with the backend database, and it will provide an HTTP API for the web server to connect to using AJAX requests. Data will flow from and to the application server over HTTP using JSON. The application server will be running Node.js with Express.js to provide the necessary API interface. Finally, the web server will be running on a third container, and it will contain the HTML, images, CSS style sheets, JavaScript, scripts, and any other static files. The application we are going to deploy is a very simple blog. The web server will handle all the static files. We will use Eduonix for this, which will act as a web server and a reverse proxy at the same time. A reverse proxy is used to route specific requests to a back-end server. Any requests that require database connection has been grouped into URLs that start with /API. Angular.js will make the necessary AJAX requests. Eduonix will automatically route such requests to the back-end application server. Angular.js then will handle the reply and generate the necessary HTML. Now let's have a look at the benefits of this microservices-based architecture. You can easily switch the application server to run any other engine other than Node.js, for example Python, Django, or Flask, PHP, Laravel, Ruby on Rails, or any other service, as long as it will respond to the API requests and provide the output expected by the front-end server. Same thing holds for the web server. You can also switch to any other technology that provides a web server and a reverse proxy. Second, if the application server or the database server is down for some reason, you don't have a complete outage. At least the visitors will see a nice error message that servers are under maintenance instead of cannot connect to server. Front-end developers and back-end developers can work simultaneously without interfering with each other's work. You can easily scale any component by adding more containers and making a cluster without affecting the other components. So as you can see, Docker here and the concept of containers can help us easily and effectively deploy an application using the microservices architecture instead of the monolithic traditional architecture. In the monolithic architecture, you would have only two servers and sometimes only just one server with everything deployed on it, the HTML, the programming language or the application server, and the database. But using a microservices architecture, as you can see, you can deploy each component on its specific container, and as you can see, Docker makes this very easy. So that was an overview of the project that we are going to work with in this section. In the coming lecture, we are going to start the actual work, so until then, take care. Alright, so let's get started. First thing, we are going to create a directory for our application. So let's go to Documents. Going to make a directory, let's call it MEAN in all caps. Let's get inside. And we are going to create 3 directories for the 3 images that we are going to create using Docker. So let's create a directory that is called DB. Another directory that will be called app, third directory that will be called web. Of course, needless to say, the first directory will be holding the database image, the second one is going to hold the application image, and the third one is going to hold the web server image. I'm going to start from the down upwards, so I'm going to start with the database. Let's get inside the database. And database actually is the easiest one. We just have to install the MongoDB. So let's open a Docker file or create a Docker file. And let's start adding the instructions that will install the MongoDB. So the first thing we're going to do is that we are going to specify the image that we are going to base our image on. Remember from the first section we said that the Docker image is nothing but layers of images stacked over each other. So we are going to use the Mongo image, and we can add the tag that specifies the edition of this image, which is 3, Mongo 3. And then we are going to run apt-get update-q for quiet and apt-get dist upgrade-y and apt-get clean, and finally apt-get auto clean. So what does this code does? If you have worked with Ubuntu before, this will update the repositories to the latest, and this will make a distribution upgrade. It will upgrade about Ubuntu, which is the image on which MongoDB is based. And this is just in case if a new dist is available, we are instructing the image to update to the latest Ubuntu distribution when it is being built, just to ensure that we are at the latest possible level. And then apt-get clean and apt-get auto clean, this will ensure that any obsolete packages are not available on the system. All of this is just to make the image as small as possible. And this is one of the advantages of using Docker, which is that the image does not consume much space as the full operating system. If you have a Ubuntu operating system, it might take 1 or more gigabytes of size. Using a Docker image, we need to make this image as small as possible. So because of that, we are cleaning any obsolete packages or any unused packages using those commands, apt-get clean and apt-get auto clean. And you might be asking, why did we put the command that way? Why wouldn't we just use something like this? Run apt-get update, and then on another line, run apt-get dist upgrade, and so on. That is because each command of those will add a new layer to the image. The image is based on a layered file system. Each command of those is going to add a new layer, and this will unnecessarily increase the image size. So putting them all in one command will ensure that only one run statement is going to be executed, and this will ensure that our image is kept at the minimum. Okay, so let's save the Docker file. Let's go to our directory and let's run our docker build command. So it's docker build -t for the tag, as we have learned in the first section. Then let's give it a name. So the name, by convention, should be the name of the directory. Then dot to indicate that we are going to build this image based on the Docker file that is in our current directory. Press enter. As you can see, it is grabbing the image from Mongo. It is pulling all the file systems, all the layers of the file system. These are the layers that we have talked about. Every run command, every copy command is going to add a layer to those. And as you can see, each layer can significantly increase the size of the image. So let's give it a few moments to complete. I'm going to speed up the video here. Okay, and now the image has been built successfully. If I run docker image ls, I'm going to have, as you can see, the Mongo, which is the base image on which I built my DB image, and the DB image itself. So what's the difference? Why we have 366 megabytes for the Mongo image, which is the base one, and 377 for the one that we just built? That is because we use the apt-get upgrade and apt-get update to download and install any new packages for the system. So that is the reason for that slight increase in the size. Okay, so now we have this image. We are ready to start creating containers out of that image. And that brings us to the end of this lecture. In the coming lecture, we are going to start building or deploying the second tier of our application, which is the application tier. So until next lecture, take care.